Okay, today we're going to look at more solving trigonometric equations. We want to be able to solve using some of the double angle identities that we've used before. Okay, this first example, they want us to find what are the solutions for x here in between 0 and 2 pi. Remember, this is boundary notation, meaning what's all the angles here between 0 and 2 pi radians. Okay, so looking at what we got here, we got sine of 2x minus cosine x. We looked at some of these yesterday. This one's not going to be able to be solved by easy algebra because we got two different trig functions here. We got sine and cosine. So what we want to focus on here is this double angle and use those double angle identities that we've looked at in the previous unit. So what we know is from those identities we did that sine of 2x is equal to 2 sine x cosine x. And so we want to take and substitute that in place here so that we can solve this one out. So substituting in now, we got sine 2x cosine x minus another cosine x being equal to 0. Well, now look for mathematical things to do. It looks like both of these two terms have a cosine x. So let's factor out that cosine x and see what's left over. So what's left over would be 2 sine x in the first term if we divide by cosine x, and the second one would be minus 1. Now we know if two things are multiplied, they equal 0. Put them both equal to 0 and solve them out. So like we did yesterday in that lesson is we want to solve both of these equal to 0, do the inverse to solve. So here with the first one, x is going to be cosine inverse of 0. So we want to put that in the calculator, see what we get. Looking here, we want to type in inverse cosine, and then we want to type in 0 here, and then hit enter. And you can see we get that answer there. Remember, pi is part of this, so we want to divide out pi. And now that leaves us with 0.5 or 1/2, so we know that the answer here we get is pi over 2. So what we want to look at next, where would that second answer be? Remember, cosine is your x value. So on the unit circle, where do we have x value equal to 0? Well, at pi over 2 we would. That's 90 degrees here. So at that point, x would definitely equal 0. We get the 0.01. The other point where it's going to equal 0 is also on the y-axis down here. That's going to be the 0.0 negative 1. And we know that from studying this, we got pi over 2. Pi, this would be 3 pi over 2 would also be the second answer there. Okay, and you'd get that if you didn't know it, take pi over 2 and add pi onto it, and you'd get that. All right, so we got two answers. These are both solutions. But now we also got to solve this one out. What do we get from the other one? So let's add 1. Divide by 2 like we did yesterday. We get 1/2. Let's do inverse sine of 1/2 to get the first answer. And if you go on your calculator and do that, you are going to get pi over 6. Okay, now you got to find that second one. Where's that second one going to be? So unit circle again. Pi over 6 is first quadrant. So we're going to get that. That triangle is going to give it to us. Sine is our y value. And it's positive. The quadrants that are going to have positive y values are the first quadrant and second quadrant. So our other answers in the second quadrant with that same triangle of pi over 6. So the easiest way to come up with the other one is to start at pi here, move backwards pi over 6 to get to that angle. So pi minus pi over 6. That's 6 pi over 6 minus pi over 6. And you get 5 pi over 6 would be the second one. So that's the other angle we get here. So these two are answers, and these are answers. All four of those would be solutions here. Okay. All right. Next example. again, they want us here to solve for all the x values between 0 and 2 pi. We again want to look at this double angle here and come up with something else we can put in, because solving with cosine equals 2x and x is difficult to do. Well, we have a trig identity from our double angle sheet that says cosine 2x is equal to 2 cosine squared x minus 1. That would be the one to use because we also see we have cosine over here. So we want to stay cosine. We don't want to mix sine and cosine if we can avoid it. So let's do that substitution. We're going to substitute in here 2 cosine squared x minus 1 being equal to cosine x. So now the next thing we want to do, get this equal to 0. So we're going to minus cosine x from both sides. So now we get 2 cosine squared x. I'm going to put this minus cosine x next, and then finally this minus 1. This should look familiar. This looks like one of the problems we did in the last lesson. Now the next thing we're going to do is try to factor that. So what's the two factors in here? Well, if we get a 2 cosine x, we know one of these has to be a 2 cosine x, and one just a cosine x. We also know that these got to multiply to -1, so these got to be 1 and 1. And then one's got to be positive, one's got to be negative. I think if we go positive, negative, that's going to work, because these two now multiply to -2 cosine x. These multiply to 1 cosine x. Those add up to a -1 cosine x we see there. All right, next up, like we did on the last problem, put both these equal to 0 and solve. So here you get 2 cosine x plus 1 equals 0. Here we get cosine x minus 1 equals 0. Let's solve them. So if you solve this first one, that's cosine x equals 1. Let's do inverse cosine 1 and see what we get. So in calculator, let's put that in. Cosine 1. We get this, which is 0. We don't even need to divide that by pi. So one answer here would be 0. And that would be the only one where you'd get cosine equal to 0 between pi and 2 pi, because the cosine is your x value, and so the only place where cosine is going to equal 1, your x value would be right here at the point 1, 0. There's nowhere else on this circle where your x value is going to equal 1. All right, so now second one, do the same thing. Here we want to subtract 1 and divide by 2, so you're going to get cosine x equals -1/2. Here it's our x value again, and it's negative. That should tell us our answers on this one are going to come between, are going to come in the two quadrants where x has a negative value. That would be the second quadrant and the third quadrant. So let's use our calculator to get the first one. Let's do inverse cosine of that. So if we do inverse cosine of -0.5 or -1/2, we get that. Let's divide the pi out of there. And let's figure out what this is as a fraction. So if we do math fraction, you can see you get 2/3. So one answer is 2 pi over 3 here. And that would be our answer from the second quadrant, because 2/3 isn't quite 1, which is 1 pi. So one answer here would be going 2 pi over 3 to there. Our second angle would be the same triangle down in the third quadrant. Easiest way to get to this one would be doing that same distance the opposite way. So if we did that same distance the other way, that would be -2 pi over 3. But we want that answer between 0 and 2 pi. So to get that, we want to take our starting point of not 0, but 2 pi and subtract that. So what's 2 pi minus 2 pi over 3? We need to get a common denominator. So let's times by 3 over 3 here. Now that gives us 6 pi over 3 minus 2 pi over 3. That's going to be 4 pi over 3. And that would be our other solution here. That's in the third quadrant. So this one has 3 solutions. 0, 2 pi over 3, and 4 pi over 3. Okay, third example here. Again, we want to find all the answers between 0 and 2 pi. So looking at this one, we got negative 4 cosine squared minus 8 sine plus 7 equals 0. We can't solve this one with both cosine and sine. So we want to focus on what can we substitute for. We can't really substitute anything in for sine because it's just regular sine. However, cosine squared, we know we can substitute for. So that one, that's not a double angle one. That one we should know very well from doing a bunch of these. We know this Pythagorean theorem, identity of sine squared plus cosine squared equals 1. And so if we solve that for cosine squared, we get 1 minus sine squared. Okay, so we want to substitute in place of this 1 minus sine squared. And what that'll do is get us only with sine in this problem. Now we should be able to solve that. Okay, so first thing, we want to get this simplified. So let's distribute this negative 4 to both. So now we got negative 4. This will be plus because we're multiplying two negatives. 4 sine squared x minus 8 sine x plus 7. Let's put those like terms together. We got a couple like terms here and here. So now we got 4 sine squared x minus 8 sine x. That'd be plus 3. Okay, now we don't have any more simplifying to do. This is where we need to do some factoring. So I want you to see if you can finish this problem. Pause the video and see if you can do the factoring now. Set both of the things equal to 0 and solve out and see what you get. All right, if you solve this one out, you should have factored this as 2 sine x and 2 sine x would equal to 4 sine x squared. Negative 1 times negative 3 would give us our positive 3 here. And if you multiply that out, you do get the two terms that add to that middle one. Solving, you're going to get sine x equals half. Inverse sine gives you the pi over 6. This is sine, which is a y value, and it's positive. So your other answer should come in the second quadrant, which is 5 pi over 6. If you put the other one equal to 0, you're going to get sine x equals 3 halves. If you try inverse sine of this one and do it on your calculator, you're not going to get any solutions for this. You're going to get error on your calculator. And the reason being, can sine x equal 3 halves? No, what's the highest that sine x ever gets? It's 1. 3 halves would be up here somewhere, and our graph never passes through that value. So there's no solutions from that one. Only two answers on this one of pi over 6 and 5 pi over 6. Okay, number 2 here, it says get a common denominator to solve. So on these ones, what we're going to do is try to come up with, again, a way to get these to be the same. We're going to solve 3 secant x minus cosine x equals 2. Well, we see that we have different values here and here. So what we want to do is try to get them to be the same. Well, we know something about secant. Secant's equal to 1 over cosine. So let's use that identity here. So let's put in for secant 1 over cosine x. Okay, so what we get now, if we were to multiply these together, these aren't both fractions, so we could put this over 1. This would be 3 over cosine x minus cosine x equals 2. All right, so next thing now, what we want to do, get a common denominator here. We want to subtract these two things, but we can't if they don't both have the same denominator. So we're going to multiply this one by get cosine x on the bottom, but that means we also got to multiply cosine x to the top. So now we got 3 minus cosine x times cosine x is going to be cosine squared x. And our common denominator now is cosine x. Okay, so next thing now to solve, let's multiply through by that cosine x. So let's multiply it to both sides to get rid of the denominator. So we'll times the cosine x to both sides. That's going to eliminate these. So now we got 3 minus cosine squared x equals 2 cosine x. Now this is starting to look more like what we've had in the past. We want to get everything to the same side, now get it equal to 0. It would be quicker just to move this over because this is only one thing, but I don't think we want to do that because we got that negative there. That's going to make it hard to factor. If we can get the cosine squared term positive, that's much easier to factor later on. So even though we got to move two things, it's going to be easier if we add these or subtract 3 and add the cosine squared x. So now we got 0 being equal to cosine squared x plus 2 cosine x minus 3. That should be factorable. So now we want to factor. We got a cosine x and a cosine x. That's going to give us our cosine squared x. We know these two other numbers now are going to have to multiply to negative 3. So our only possibility, I think, is either negative 3 and positive 1 or positive 3 and negative 1. If we know they got to add to positive 2, it looks like we want a positive 3 and a negative 1. Okay, so now put these equal to 0. So we got cosine x plus 3 equals 0. That means cosine x is going to have to equal negative 3. That's not going to produce any solutions, though, because we know that the range of cosine x is between negative 1 and positive 1. So that one won't produce any solutions. You can try inverse. It won't give you anything on your calculator. This other one, though, cosine x minus 1 equals 0. That means cosine x equals 1. There should be a place where cosine x equals 1. Do inverse cosine of 1, and you are going to get the value of 0. Only place where cosine x equals 1 is at an angle of 0, because the only ordered pair where x is 1 is right there. So only answer on this one is 0. Any other angle's not going to work. All right, last problem. This one, again, we were going to look to get a common denominator. So why don't you start by looking what can we put in place of cosine x here, and see how far you can get this equation simplified knowing what cosecant equals. So pause the video and try it out. All right, let's see how you did here. First thing we know here is that cosecant is equal to 1 over sine x. So we're going to substitute that in place here. Combine these two and multiply, and you get this. We got to get a common denominator now, so multiply by sine x over sine x. We're going to result in this now, this fraction. We want to multiply that sine x to both sides. That's going to cancel this out. So now we got 2 minus sine squared x equals sine x. Move everything to the right side. I moved everything over to the right side so that this sine x squared term is positive. Now we should be to the point where we can factor. So see if you now can pause the video again and try factoring this out and solve for the solutions. All right, let's see how you did. If you factored this correctly, you should have came up with this. Looking here, what's going to multiply to negative 2 and add to 1? That would be positive 2 and negative 1. So now put both these equal to 0. Here you're going to get sine x equals negative 2. We know that sine x doesn't ever equal a value of negative 2 because the y values are always going to be between 1 and negative 1. So there's no solutions there. For the second one, where does sine x equal, or sine x minus 1 equals 0? That'd be where does sine x equals 1. If you do inverse sine of that, you get the answer of pi over 2. And that should be the only location because sine x is our y value. The only place where you get a y value that has a value of 1 is right here at 90 degrees or pi over 2. Nowhere else will you get a y value of 1. So that would be the one location there. So the only answer you should have got is pi over 2. All right, what you should work on now is trying that second Unit 5 worksheet.